Today, I'll be talking about a Python program that helps you learn the notes on the guitar fretboard. I'll start by discussing some basics of music to give you a better understanding of how my program works. Then I'll discuss other programs and software that inspire me to make my program. And then I'll break down my code and give you a demo of how it works. And then finally, I'll talk about my future plans for this program. Okay, so going over some basics of music, we're going to have frequency, pitch, and notes. There are, of course, a lot more to music than just that, but this will just be the basics to help you understand. So frequency is going to be the cycle rate of a waveform. We see this in the bottom right photo. If we look, this is a pretty slow wave, and this is going to result in a lower frequency. If we look at the one below it, it's much tighter and it's faster, and this is going to result in a higher frequency. A frequency is more of a mathematical measurement that we can take, so it's very objective on what it is. And then for pitch, it's more subjective because everyone perceives pitch as different, but pitches are how high or low you hear a sound when it is produced. So a low frequency oftentimes will produce a lower pitch, a high frequency will produce a higher pitch. And pitch relate to notes because we assign notes to these pitches. So for example, we have a C note, it's going to have a designated pitch assigned to that note, whereas D will have a designated pitch assigned to that note, and that's how we tell notes apart. It will also have the frequency assigned to it too, but we don't really notice a sound by the frequency, we notice it by the pitch. And in this top right photo, another thing I'll discuss is there are 12 notes in the musical alphabet. So we see C, D, E, F, G, A, B, and then it repeats again, C, D, E, F, G, A, B. This will repeat all the way down through, and there will only ever be 12 notes. And this isn't 12 notes right here. This doesn't include the sharps and flats, but if we look at the black keys, this would include the sharps and the flats. So like C sharp or D flat, and then D sharp or E flat, and so on, so on. Okay, so this will be a very basic understanding of how the guitar works, and I'll explain some things. So on a standard guitar, you're going to have 6 strings. These 6 strings all are going to be having a note attached to them in standard tuning. So for example, the lowest and thickest string right here is going to be an E note. The next string is going to be an A note. The next is going to be a D, then a G, then a B, then an E on the last note. And we notice that these two are the same, so E and then E. So when we have the same note, we say that that's an octave higher or an octave lower. But since this is a thicker string and this is a thinner string, this thinner string is going to produce a higher pitch or a faster frequency, and yeah, it's a higher octave. Now, on a guitar, you're going to have roughly between 18 and 24 frets, depending on the guitar, and these frets change these pitches. So we can tell the frets right here, they're divided by the wireframes, these little metal things right here, and that's the frets. So this would be the 5th fret. So 1, 2, 3, 4, 5. For example, if we were pressing down on the lowest string, which is the E, if we were fretting that, if we look at this chart here on the 5th fret, if we're fretting on the low E string, it would be an A note. So by pressing down on these frets, it changes the frequency and then changes the pitch. So when we pluck that string, it's going to cause it to vibrate, and that's going to be the frequency. And then once that cycle starts going, it's going to produce a pitch. And yeah, that's how the guitar works. Okay, so now that I gave you a basic understanding on music and the guitar, I'll discuss some of these programs out here that try to teach you the guitar fretboard. So we've seen in the last slide that in that bottom right graph that each note on the fretboard or each position on the fretboard produces a different pitch or has a different note assigned to them. Now, learning your fretboard and learning where each note is a very hard task to do and very hard to master, but there's softwares out there that go to try to teach you this, and learning this as a guitarist will tremendously help you in your journey. So this program at the left, I'll discuss how it works. We see that we're on the high E string and there's this red dot. We also notice that we're on the 5th fret, so we would look at a chart or look at our guitar, be like, hey, that's an A note. It would then turn green, and then this would count up in the percentage. If we got it wrong, we may get another chance. It may move to a different note, may subtract the percentage. I don't know how this one works exactly, but it would be something along the lines of that. And I do like that it counts it, and it counts a percentage. Moving to the software at the right, we see that there is a countdown, which I really like. I think that adds a challenging element to it. And see that there's a green note on the 1, 2, 3, the 3rd string, which would be the D string. And we notice that it's not on a fret, so this would be just the D note. And yeah, you click it, and I'm guessing it move on to the next note. I like the idea of the timer, and I like the idea of the percentage, and I think that's really cool. But my biggest problem with this is you're not holding your guitar. That's such a big thing, is you could sit here all day and get good at this, but if you've never touched a guitar before, it'd be very hard to apply this to the guitar. So I would like for this to have an element of that, but it doesn't. So my plan for my software is to, of course, include some of the basics that those other softwares that I was showing you could do. So I think it'd be cool to have a timer and have a percentage. And of course, I'm thinking more spitting out a note. So like play the A note on the E string. You hit that, it'll say correct, move on to the next note. If you stay on a note too long, for say 30 seconds, depending maybe if you're a beginner, we'll give you 30 seconds. If that doesn't, you can't get it in that time, we'll move on to the next note, and so on and so on. And I'd also like this to be a hands-on experience with the instrument, so you're holding your instrument, it detects what note you play, it sends it through either a mic or an audio interface, and then it tells you whether it's right or the wrong note you played. And I also would like to add a beginner, intermediate, advanced mode, game mode, and a playground mode, where beginner, intermediate, and advanced would keep it where anyone, no matter your skill level in guitar, could be able to use this program. And then a game mode to keep it challenging and fun, maybe some like 10 notes, keeps your high score. I think that would be very cool. And then playground mode, which playground mode would be just a tuning mode. You could use it to tune your guitar, but how it would work is you play whatever note you're playing on the guitar, it would tell you the pitch of that and the frequency, and yeah, you could just see what notes you're playing and play around in that. Okay, so before I start breaking down my code, I need to explain what an HPS tuner is because it is implemented in the code. So an HPS tuner pretty much just takes a different period of frequencies and determines what the overall frequency is and the loudest frequency. So seeing the right over here, that we have all these different frequencies, which are these different peaks. You see that some peaks are louder than others or taller, and that is important on how this works. But the reason why we have so many different frequencies is because when we hit a single note on guitar, it's not going to be just one peak. You're going to get a lot of different because your guitar is going to produce overtones. And dealing with all this, you'll probably get spectral leakage, which is just more unwanted frequencies that are not true to the pitch. Yeah, and we see these could be different graphs over milliseconds, but what it's doing is it's taking the loudest pitch over a period of time, or loudest frequency over a period of time, and it's chopping off everything else, averaging it out, and this is the frequency that we're at. So yeah, it can determine that. Oops, I didn't mean to do that. But over here we have to the left a guitar. Again, these are just the open strings, and you see we have E2, A2, D3. These little numbers at the ending, or just what octave they're in. So see this E2, this is E4, they're the same note, but they're different octaves apart. This is a lower frequency, and this is a higher frequency. It's 2 octaves higher because E4, E2. E2 is going to produce an 82.41 hertz frequency, and all this shown is the measurement of frequency. So if we look down here, whatever note we're playing, we see that the frequency is on the bottom. This is probably around the 400 range, maybe even, yeah, probably around the 400. We see that E is 329.63 hertz, so most likely we're somewhere in that range, maybe even an F4 would be my guess is what this note is, somewhere around there. And we could have like a range that determines like if it's within that, then that's that note. So it's kind of how the HPS tuner works. It just chops all the bad frequencies and determines the best by the loudest peak. Okay, so I'm going to go over the code that inspired me and gave me a start to create this program. So this is code from Chicken, and all it is an HPS tuner. So it'll tell you what note you are playing. So we can see here that we've imported Sound Device and NumPy, and yeah, Sound Device just pretty much is going to take in sound, and whether that's through an audio interface or a mic. NumPy, what it's going to do is just be some mathematical operations for arrays and such. We have some global variables here. A lot of these are just for the graphs and stuff, and like time windows for how long we're going to take in a sound for and stuff like that. We also have power threshold, which this is important because how much sound do we need to come through to actually take in? So for example, if we're playing an electric guitar without an amp, which is going to be pretty quiet, we may want this to be a lower number because the lower it is, the more sensitive it's going to be. If we're playing acoustic or an electric with an amp, we probably get away with this being a higher number because it won't be as sensitive. But the downside of being super sensitive, it can pick up a lot of background noise. We also have like a white threshold, just white noise to cut it out. So there's a lot of stuff going on here to make sure we're getting a pure sound, and we can modify this to our liking. Although global variables shouldn't be modified, but power threshold might be valuable to modify. As we can see here, we have all of our notes in music. We have some functions. This is just going to determine what pitch that we're receiving is closest to the note and assign that to a note. We see here that we have a window which is going to take in a sample. So however long we're playing, it's going to pin that to an array, and then at the same time it's going to be removing it consistently. So it's always going to be adding new and then removing it consistently over a period of time. That's just meant for the graph. And then here we're just going to be skipping our signal power if it's too low. That's what I was talking about with the power thresh. Same thing with over here. If the power's too low, we're just going to skip. Oh, also we will have some stuff to get rid of spectral leakage, because with all these operations and stuff, we're going to get unwanted stuff and spectral leakage from the graphs. Then this down here is going to calculate the average energy per frequency of the octabands and suppress everything below it. Yeah. And then we have a spectrum that's being created, and then we are actually getting to the heart of the HPS tuner right in here and what that's doing, and that will also output what our closest node is down here. And yeah, down at the very bottom here is just going to be, you know, the greetings to starting the tuner. And that's kind of the basis of his code. So he would say start an HPS guitar tuner. It would consistently create this window sample that's going to be taking in input and be appending it to array and then removing the array. And then when you're playing, it's going to determine what sound you're playing and assign the pitch to a note. And yeah, we can see here it's going to call that frequency right there, and then yeah, find closest note, and it's going to throw in the frequency, and then it's going to assign the note that you're playing to it. Yeah, and then it would be closest note, and then it would keep refreshing over and over again and show you the note. I will show this in a live demo, so kind of you can see what it's doing better, and it's probably better than I can explain. But if you do want to learn more about this is pretty interesting. I'll leave a link to his webpage that explains this code, and yeah, it's pretty cool stuff. Okay, so I'm going to go ahead and break down what Chicken's code is meant to do. So I'm going to run it. Okay, so we see it's consistently refreshing and it's picking up my voice. That's why we're getting different notes. It's consistently refreshing because we're always bringing in new samples and dumping out the old, and it's going through the calculations, and it's just going to keep refreshing. But if I'm like quiet or if I whisper, it won't pick up the voice because it's not exceeding the power threshold. So like if I was to lower the power threshold, then of course it would be more consistent if I whispered. I'm going to show this with a guitar, what it's meant to do. So this is a tuner, so I'm going to tune this guitar a little bit. I didn't mean to bump it, but I'm going to, so I'm playing an E string. And I know this is an E just because it just is an E string. But right now it's a D sharp, so I know I need to go up. So we see it, we're in the E at 81 hertz, but the true frequency of an E is 82.4, so I need to go up a little bit more. So I'm pretty much on the dot with an E, and you can do this for every note. So A is perfect almost. So this program is really good for trying to tune your guitar. It works great, but I can use this logic of, hey, that's the note you're playing, and I can spit out notes and determine whether the note is the same note as I want them to play. So this kind of gives you an idea of like how I got my thought process to start, and yeah, I'll begin talking about my code next. Okay, so I'm going to begin explaining my code and how I modified Chicken's code to make my code do what it needs to do. So I think I'm going to start with the bottom down here. So this is going to be my greetings menu. I'll go ahead and display what it will look like. So if you look down here in my console, welcome to guitar note practice, ensure your guitar is tuned, you can check in playground mode. We have our practice modes, and here I've defined what each mode does. And I can also, I'm taking an input, so if they enter bad input like that, it's just going to keep repeating with a loop. If they enter a lowercase, it will work though. So that's what this does right here. I'll go ahead and explain a little bit more on what each of these do. So right here, I'm taking in the practice mode that they enter, and I'm uppering everything they enter, just in case they enter lowercase, it will still count. And then I'm error checking this right here with making sure they entered one of those key practice modes. And then if they don't enter some right, not valid practice mode, and then they can try again, and this will go on forever. Down below here, when they do enter in some invalid, it's going to send them the correct place. So we will clear the console, which is a function I created, and I'll explain here in a minute, and then we'll send them to beginner mode, and I'll explain that as well. So if we scroll back up, you can see I've added these global variables right here. So I've added all the strings, which are just the basic 6 strings on a guitar, and starting from the low E all the way to the high E. I've added all the natural notes in a list, which are just all the white keys, no black notes. And then I've added all the notes, so including the white keys and the black keys, but only the sharps. I didn't add the flats. I think eventually I'd like to add the flats, but for now, I've just added the sharps. And then I have the closest note, which this is mostly just a placeholder. And then I have is tuner mode, which is set to false, which this is just to determine that we're not trying to tune the guitar, we're actually going to a practice mode or game mode. Um, if we go on down, this code right here, I've commented a little bit more out to try to explain things better, but this is like chicken, or well, this is very similar to the chicken's code with a little bit of modifications down through here. But this pretty much is just going to return a closest note and a closest pitch like before, and it will determine what octave it's in as well. And right here you can see some of the math formulations it's doing to figure these things out, and where I've commented them. And then if we keep going down through here, we see I'm using the is tuner mode false, so this means that we're not trying to tune the guitar. We will take in input from the sound source, and we'll make sure that the signal power is not less than the power threshold. So if there ain't a lot of noise coming through, then we're not even going to pick it up. But if it is greater than, then we will display. So we'll print a string and then a note attached to that. If we keep going down, the else to this is if they are trying to tune their guitar, then we'll just display the closest note they're playing, and it will just sit there. I'll explain this again because it goes hand in hand with my code below with the values it receives. If we keep going down here, this is more just to make sure we get a clean signal and stuff like that, and then the HPS tuner like before in the other code. Now here we get to the playground mode. So the playground mode is pretty much just a tuning mode, and it can be used to explore your guitar fretboard. So when you hit a note, it'll just tell you the closest note, max frequency, and closest pitch like the code before. I wanted to add this in because I think that's pretty useful, and it's good to keep your guitar in tune for this program to work properly. We can see that we're taking in the mode. So if the mode that they entered is P, then we'll go ahead and print the closest note and the max frequency and the closest pitch that they're playing, or else we'll just sit here steady with the closest note and keep refreshing. And if all else fails, we'll just print no input. Then I have the clear console function I was talking about. So all this does is just clears the console. This is useful for when transitioning modes or transitioning from the greeting screen to the actual practice modes. I have this countdown right here, which this countdown is just a 3, 2, 1 countdown. I really don't remember if I used this anywhere, but I do like the code for this. It's cool. It just counts down 3, 2, 1, all just 1 second, and yeah, I like this. But I may have used it through here. I'm not sure. If I find it, I will show you. But I have the beginner mode, which the beginner mode is, of course, if they just enter B for their mode, and you see I've set the mode to B. This is to determine that the mode is not the playground mode, is the reason I've done that. If we keep going, we're going to get introed with welcome to beginner mode, and then we'll wait 1 second in the console, and then we'll use that clear console function. And then I'm creating a random strings list, which is going to take the 5 strings that I defined way up towards the top, or 6 strings I defined way towards the top, and it's just going to put it in a random order. So it could be A string, low E string, high E string, D, etc. Just in a random order. Same thing with the natural notes, so no sharps will be in here, just the natural, and it's going to put that in a random ordered list. Then from there, what I'm doing is I'm having a nested for loop, which is taking these strings and it's just going to loop through each one and pair each one with a note. So low, for example, if we start with the low E string, it's going to get paired with each note just in a random order all the way through, and then it'll go to the next string and do the same thing until we're done. So you can see we'll get our input from the user, we'll take it in, and then when the note does not equal the closest note, we'll sleep it, but if it does, then we'll print correct. And that means that they have played the note that was closest to the note. And I'm using the 0 here to get the index of the note, because if we go up here, what Chicken's code is doing is when it returns the closest note, it's going to return one of these notes. So it's going to return an A sharp, a B, a C sharp. So of course this is the 0th index, and then this will be the 0 then 1 index. So we just want to get the 0th index in my beginner mode, because we won't have sharps. We'll always just be that one note. So that's why I'm doing the 0 here. We'll just sleep the time if they're wrong, and we'll keep waiting over and over again until they enter the right one. And when they do enter the right one, we'll print correct. We'll give it 1 second, we'll clear the console, and then we'll go back up and we'll go for the next loop. When they've went through all of them, then we'll just print thanks for playing, and if all else fails, I'll just print the exception that displayed. Now I follow this pattern very similar in the intermediate mode, which is just you can see it's very similar in the variables I've defined, and the mode, same thing, I determine as I, just to determine that it's not the playground mode. I have an intro, it sleeps, clear console, same thing, I've created a list. The difference here is this list will be all notes, so this will include the sharps but put it in a random order. And then I have a nested for loop again, which is just going to display a string, and then the note compared to that, put to that string in a random order. And then we can see that I've added this new logic here, which is if the length of the note is equal to 1, so the note is a natural note is pretty much what this is saying. And because we won't have a sharp attached to it, we're going to make sure that that's a natural note. That's what we're going to test for first. So same thing down here, while note does not equal the closest note 0. You see here, I'm using the 0th index. This is to determine that this is a natural note, and if it isn't, then we're just going to keep sleeping until they get it right. Once they get it right, we'll wait a second, clear the console, and then we'll go to the next string and note. And when I'm calling these things, I don't know if I explained this, but this is pretty important. If we go back up, I meant to say this is where it's printing to the display what they need to play. So it's receiving that string that we're on, and then it's receiving that note. And yeah, so that's how that's doing that until it gets some right, and how they know what they need to play. It's just receiving that string and that note right there. But down here, yeah, string and that note. Depending on the mode that they pick. But if the note that they didn't pick was more than a natural note, so there's two things attached to that string, so like instead of it just being A, if it was an A sharp, of course that length is 2, so we're going to skip all this code right here, and then we're going to go down to this code right here, and then we know that we're looking for two things. So we want to make sure that the note that they're playing does not equal the index of the A sharp. Hopefully I'm making sense with this. So like these two, we want to make sure that it won't equal like this, the 2. That's what we're checking for here, instead of just the 1 index or the 0th index. We're checking for the 2. And if it does equal that, so for example, if it did equal A sharp, then we'll just print correct, and we'll go to the next note in the string. So, and when they finish this, then we'll print thanks for playing, and same thing, we'll catch any exceptions. Now, my advanced mode, I tried a lot of different stuff for this, but in short, I was unable to get this to work, and I'm pretty upset about it because I did want it to work. I try to think of a lot of different ways to do it, but unfortunately I was unable to. So this mode is not working. Yeah, and I should probably make a little note of that, not in that, but yeah, I'll just leave that there so I will know. Now the game mode, I had to make modifications to this to make it do what I want, and it's not perfect. If I could get this advanced mode working right, I could have my game mode working a lot better, but I'll do my best to explain this game mode. So, unfortunately, I don't think I'm using much of these that I've defined other than the top ones and the counter, but how this is going to work is we're going to print the game mode, just the simple intro I've been doing. We're going to get all the strings, all the notes, and then what this program is going to, or this little section of my code is going to do, it's just going to display 10 notes, and then that will be it. Instead of them being overwhelmed with going through the whole fretboard, which is good practice, they'll just go over 10 notes, which I think is way more relaxing and like might be a different way to learn. So as you can see, we're doing this again, just getting the random list and the random of all notes, and then we have the nested for loop. Or make sure the counter is less than 10, and if it is, we're gonna wait until they get one right. Once they do get one right, we'll add one to the counter and we'll keep going. Now if this counter is more than, we'll just wait, take that back. We're gonna first test for if it's a natural or a note with a sharp, and if it's a natural note, we'll do this code here and wait until they enter the right note, and then we'll add to the counter. If it was a note with a sharp, then we'll use this code here because it tests for the sharp notes, and then we'll go ahead and wait until they enter one right, and then we'll add to the counter. And that's what that code does, and when that's finished, it just says thanks for playing. I would like to add a score and a total to it, but I have no way to check, or a way that I can think of to check to see if they're entering the wrong note or the right note, because it's going to be picking up background noise, and this program is not 100% accurate on picking up the note, so I would feel bad for them to pick up background noise, they get that wrong, and it skips to the next. So I need to work on this and the advanced, to get it the way I want it to work. And I feel like the game mode could be a lot more fun with a high score and stuff like that, and maybe more of a countdown so you're timed. I think that'd be more game-ish, and yeah, I think that would add a lot to this part. Now back to the playground mode. Again, this is just the simple playground mode. We're doing the is tuner mode. We're now setting that to true. As before, is set to false by default. When this is set to true, if we go back up, we'll see that I have modified it. I think it was a little bit higher. Right here, yeah, is tuner mode false. We won't use this one. We'll instead use this one, which is just going to print the closest note. And it'll keep refreshing that until they enter the right one. And when they do enter the right one, we will... Actually, it will not test if they're entering in anything right or wrong. It's just going to display the note they're playing. So, yep, that's what this code would do. And if all fails, then we'll just get the accept. And while his tuner mode is true, we'll just keep refreshing every half second. So, yeah. And then, so that's what the playground mode does. And so that's pretty much the code that I've made and how it works. Yeah, and I think I'm gonna demo it now. Okay, so I'm gonna go ahead and demo this code. I have my mic put down to my guitar, and yep, I'm gonna go ahead and run this. Now, I don't know how well this will work with OBS running with this program, because OBS is also picking up mic input, and this is too, so I don't know if it's going to interfere at all. I'm gonna go ahead and open up the playground mode to make sure my guitar is in tune. So I'll just demo a little bit of this. So I'll start with the E. Okay, so yep, that looks pretty good to me. A, and then G, or D, and then yep, that looks good too. So yeah, you can go through that with all the notes and make sure they're all in tune, but my guitar is in tune. Then I'm going to go to the next mode, which is the beginner mode. Now this will just give us natural notes, so we're on the D string, so E, A, D. We're going to look for an F note, which I'm not great at this, but I will try. So I hit an F, it said correct, we move to the next. Now we're looking for a C note, which should be, I believe, right here. Yep, correct, move to the next note. D note, actually for this one I'll show what happens if you get it wrong. So you see that the program took an input because it kind of froze like that, but it's not correct, so it keeps going. But when I do enter in something correct, we move to the next note. So that's what the beginner mode does. I'm going to go ahead and move to the intermediate mode. So you see we're starting out with a sharp. So we're on the G string and then a D sharp. So D sharp, A, B, C, D, D sharp. Correct, we move to the next. Now we're on a C sharp, which should just be below it. Now we're on an A note, so you see it does sharps and the naturals. And A should be right here. Correct, we move to the next. And if I hit it wrong, oh, I accidentally hit the C note. But if we hit the C again, you see it doesn't move on to the next one. Yeah, so it will just go through all of those and then it'll say thanks for playing once you hit the bottom. Now, of course, I didn't get my advanced mode working. I would like to have it to where you're timed. I feel like that would add an element of being advanced, or maybe if I ever added flats, it would have a random order between sharps and flats. I think that would be wise. But I'll show you the game mode. Just game mode's not perfect, but it's okay. So we will have a D and then F string. So this is my D and F. Correct, we move to the next note. Now what this will do is it will go through all 10 of these notes, and once it does, the program will end for game mode. So that's all that will do. To prove that, I can just turn this down just so I don't have to do 10. So I can set this timer or the counter to 2. So for example, now it'll only do 2 notes. Go ahead and run this. That's not much of a game mode, but it will work. E, A, so A, and then F sharp, which the F will be B, C, D, E, F, F sharp. Correct, and then we should get one more note. So that's easy, just open. And then thanks for playing, the program ends. I do think it'd be cool to add a high score and a timer, and yeah, I think that would be pretty neat. And it'd be cool if I could find it to where if they are hitting the wrong note, that it skips to the next. I think that would be cool, or maybe a try system where they try so many times. So that's pretty much what my code does. Okay, so now that I've went over my program, I just want to go over some of my future plans for this program. So I would like to implement a timer for all the practice modes for B and I and A. I think it would be cool if I could somehow add a timer that counts how long it takes you to finish going through all the notes on the fretboard. I think that would be pretty cool because you could see how much you're progressing, and it would let you know, hey, you did this 20 seconds faster from the last time. I think that could add some encouragement to the program. I would also like to implement an advanced mode to have flats and have a countdown timer. So for the advanced mode, I think it'd be cool if the sharps weren't just sharps, they had flats involved too. But I would have to find out a way to, when the sharps are displayed, make sure that that flat that corresponds to that sharp won't be displayed as well. And I think a countdown timer would be cool for the advanced mode as well, so that it counts down. And your time, that would add a challenging element to it too. And also, I think right now my program, the way it works is the strings, it'll start with a string and go through all the notes on that string. I think for an advanced person, it would be cooler if it could randomize that as 2. So it could do like low E string, A note, then it could go to A string, B note, instead of it being low E string A, low E string D, low E string E, it could skip around the strings and the notes. I feel like that would add a challenging element as well. Then I would like to implement a high score and a countdown time for game mode. So for example, if you're only getting 10 notes in game mode, it'd be cool to have a countdown where they have to find that note in, say, 10 seconds. If they don't, it skips to the next note and they don't get a point for that. I think that would be cool to have sort of that high score feature into the game mode, but I'm just unsure how to do the timers. That's kind of what's holding me back here. Finally, I think if I can implement all this, it'd be cool to create graphical user interfaces for this program. I think it would be cool to display a guitar and then it show you the note you're playing, and then you just go play it on your guitar, kind of similar to the other programs, but instead of clicking, you could just play. I think that would be very neat and cool and useful. I'm just unfamiliar on graphical user interfaces with Python. I may be able to convert this program to something like C# because I'm more familiar with how to use graphical user interfaces in that. So yeah, that's just some of my future plans for this program, and when my knowledge improves, I would like to add some of these things. Finally, if you would like to learn more about where I got some of my information and more about the HPS tuner and how it's working, and if you would like to see Chicken's code, I've linked all of that. He explains how the HPS tuner works very well, and he goes in depth, and he really can probably do a better job than I can explain it. And his code is really impressive. And yeah, if you'd like to check that out, you can just copy this link and paste it in and check it out. So that is my program. Hopefully this meets expectations, and thanks.